Hello and welcome back to another holistic education video. In this video, we'll be continuing our series on the 25 hardest SAT math problems of this year according to Prep Maven. In this video, we'll be tackling problem number 12, which is a very long word problem which may seem very complicated at first, but is actually quite simple once you decipher what it is asking you. So it says, for an electric field passing through a flat surface perpendicular to it, the electric flux of the electric field through the surface is the product of the electric field strength and the area of the surface. A certain flat surface consists of two adjacent squares where the side length in meters of the larger square is 3 times the side length in meters of the smaller square. An electric field with strength 29 volts per meter passes uniformly through this surface, which is perpendicular to the electric field. If the total electric flux of the electric field through this surface is 4,640 voltmeters, what is the electric flux in voltmeters of the electric field through the larger square? Once again, a lot of words. It can seem very complicated at first, but let's go through it sentence by sentence. The first sentence is generally telling us that the electric flux of a field is equal to the product of that electric field strength times the area of the surface. So let's write that down as an equation. And we'll just say, in simple terms, that the flux equals the strength times the area. That's what it's saying. The electric flux of a field equals the strength of the field times the area of the surface. Now, whenever you see in a word problem like this, some relationship that is described that can be expressed as an equation, you better believe that's the equation that's going to be used. So this equation is what we're going to be using in our problem. The second sentence describes a surface consists of two adjacent squares where one square has side length 3 times the other. So if we draw what this might look like, we have one smaller square, and that'll be next to a bigger square. And if the smaller square has side length, let's say x, the bigger square we know would have side length 3x. So now that we have this, we can calculate the surface area of the entire surface, because this square with side length x is going to have area x squared, and this square with side length 3x is going to have area 9x squared, which means the entire surface together is going to have area x squared plus 9x squared, or in other words, 10x squared. And then the next sentence after that gives us a description of a specific electric field that's passing through it, which it says has a strength of 29 volts and has an electric flux of 4,640. So now we can use our equation to solve for x, because we know that 4,640 equals 29 times the area of our surface, which we have figured out to be 10x squared. And we can now solve for x. We'll multiply this 29 times this 10 out. We'll get 290x squared. So we have 4,640 equals 290x squared. If we divide both sides by 290, we'll get 16 equals x squared. And if we take the square root of both sides, we get x equals 4. So we figured out that x equals 4. And finally, the last part of this problem, what it's really asking us, it's asking us for the flux through the larger square. We can use this same equation while only using the area of the larger square, and we can find that the electric flux that we are looking for equals the strength 29 times 9x squared, but now, of course, we know that x equals 4, So 9 times 4 squared. And if we multiply all this out, we will get that the flux equals 29 times 9 times 4 squared, which is 16. And if we use our calculator to multiply all of these out, we will see it comes to 4,176. And 4,176 is indeed our final answer. So what we did is we deciphered the problem. We found the relationship that it was describing for us in terms of an equation. We found what our surface looked like and how to calculate the area. We used all of these factors to solve for x, to find this value x, and then plugged it back into the equation for just the larger square so that we could get the flux through only the larger square, and we got 4,176. Thank you so much for tuning in, and I look forward to seeing you in the next one.